Hey class, are you ready to go diving today?
No. What if I dive in and never come back up, or if I drown before they reach the surface?
Oh, well this pool isn't that deep. It doesn't really matter what conditions you're in.
Well, what if it's corn syrup and I just can't tell? Or what if it's so white that it just swallows me?
Oh Timmy, you're being dramatic. That wouldn't affect you.
Fact check. I think an experiment's in order. To the lab! This experiment was conducted using Vernier Video Physics motion tracking software. It was set to record a jar filled with a liquid with varying density and viscosity. The three liquids tested were alcohol, the least dense and least viscous, water with medium density and viscosity, and corn syrup, the most dense and viscous. An object was placed in a tube going into the jar. The tube was sealed, pushed down, and then released. This caused the object to oscillate with the liquid, and this oscillation was recorded and tracked using a slow motion camera. In addition, the jar was replaced for a smaller one to see how container size affected the oscillations, along with the use of a large and small tube. Variations were done only using water. The resulting damp signals were filtered and analyzed using this fast Fourier transform.
Teacher, the data is in. After comparing the isolated variables based on the calculated natural frequency and amplitude, it is seen that increasing jar size had no effect on the natural frequency and a small increase effect on the amplitude. The increase of viscosity and density decreased both natural frequency and amplitude, with the effect of viscosity being much greater. The tube size increase caused a decrease in the natural frequency.
Oh, wait, what?
What this really means that while the pool is not going to swallow you up due to its width, because corn syrup is very viscous and an over-damped system, you may take a long time to rise to the surface. And even more so, technically you would never float to the surface without effort, but only approach it indefinitely.